Okay, hello everyone. Thank you very much for the invitation. Right, so what I want to talk today about is a bit what happened yesterday with respect to questions of how we're talking about democratic processes, co-creation processes, but sometimes we're missing the big picture of what is going on in the system. And so the wrong decisions can be taken if things are not put into context. So for example, when we are thinking about the very local scale of the neighborhood, the person might not be aware what's happening at the larger scale of the city. And when we think about the scale of the city, we don't know what's happening at the level of the country and so forth. And at the same time, when you think about interventions from the government in which you say, okay, this is going to trickle down to all these different cities, which cities really are these going to be affected by the decision at the level of, at the regional level? Because the connectivity of the system, of how the people are interacting, might be very different to the governance system. So this is one of the big examples of having a myopic perspective of what is happening, taking decisions at the level without realizing what is the role of each of the cities within the bigger city and the role of the whole country within the bigger perspective, for example, in this case of the UK and the European Union. So, okay, we understand we need to take into consideration the different scales, but how do you really figure out which are the scales that you are considering? So if you think about an individual scale, then you will be missing some of the other ones, but how to then make aware of the individuals that is taking the decision of the bigger picture. And that is very problematic to try to put context into the whole different scales. It's very problematic trying to understand what is the relationship between the elements at the different scales, between the cities that belong to the regions and the regions that belong to the wider context, for example, in terms of infrastructure and so forth. And so what I'm going to talk today about is how we can think about the relationship of all these different scales and try to characterize, for example, cities in terms of the relationship of the different cities in this context. So what do I mean? So if we're going to take a decision in a city, is this city an employment hub? Is this city one of the cities that needs a close relationship with this other one in order to be able to complement the sort of industries that are taking place? Or what sort of city is it? And how to do that. So we're going to be building this relationship in terms of the interactions between the different components. How can you assess this type of interaction? So we're going to focus on commuting networks. So these are the sort of interactions that we're going to look at in order to look at the dependency. And so commuting networks, we're thinking about employment networks, okay? So we're going to be thinking about the dependencies of the different cities with other ones. So which are the ones that are the employment hubs, which are the ones that are capture these individuals, and how we can think about it at a larger scale of the whole system. But of course, when we think about this kind of dependencies, we also need to think about diversity, yes? So it's not the same to be a city that is attracting people from many other ones, or a city that is giving, that is the one providing the employees to all the different ones. What sort of skills have these individuals, right? So why sometimes infrastructural projects don't work? Because you don't consider the type of skills that you have at one level and who are the ones that are capturing this talent. So considering this relationship between the two is very important. So this is why we're going to be looking at diversity. So diversity of the flows in terms of the spatial, the heterogeneity of the interactions in the system. Yes, so that's the diversity of where I commute from, who I'm capturing from other cities, but then at the same time, the diversity of employment, okay? And why? So, of course, these type of things are very important in terms of adaptability. So we want to know if all of a sudden you break one of the relationship, who is going to be able to fill in that space, okay? So what is happening at that level? Also, with respect to understanding the role of these cities, are they monocentric? Not only the cities, but what about at the regional level, or the polycentric, and so forth. And of course, the last point, which relates to this idea of I'm injecting some money, some sort of intervention at the regional level, who is going to benefit from this? And most of the time, the cities that are benefiting from this are not the ones that you thought were going to benefit, because the structure of the system is very different to the governance structure. So I'm very happy to present the work. This is work done by Valentina Marin, who recently obtained her DR in front of her name. So this is the paper where you can find all the results that I'm going to be presenting today. And Valentina is from Chile, and she took Chile as a case study. And she developed the following framework. So the whole idea is that you have your system and you have your interactions, which are heterogeneous interactions. And so, of course, that will give rise to a hierarchical structure of the system. So how can we recover this hierarchical structure through the interactions that you observe in the system, and not from the imposition of the governance structure? So once you have a hierarchical structure in the system, then you want to see different kind of characteristics of these cities within this hierarchy. How do they change? So I am very diverse, but within the wider context, maybe, you know, I am the most diverse one, or I'm not very diverse, but I need this other one in order then to be able to be diverse. So how does it change with respect to how you scale up the system in terms of where it is in its region? Then we're going to see the relationship of these elements in this hierarchical tree. So things that might be that might look to be very close, especially, actually, they're not very well connected. Things that might be look very close, spatially, actually, they're not interacting, because the type of employments are not the ones that people want to do in terms of the skills that are in this other part. So we're going to look at this relationship in terms of the distance of these elements inside the tree. And lastly, once we have all these elements, then we will be able to classify the cities according to how they behave, but at the full scale. So once we have that, then we can make a decision with respect to who am I in this whole system? Who am I with respect to all this hierarchy? And not only from the myopic view of what I can see around myself. Okay, so the first part is the hierarchical organization of the system. So this is Chile, and its governance is organized like this. So you have communes, you have provinces, you have regions, and you have the whole country. And when you look at this type of organization, it's very centralized, and actually it's one of the most centralized countries in the OECD. Okay, so this is how, in terms of governance, it is structured. And for each of these provinces, well, for each of these regions, you will have a capital city that is like the one that is meant to be providing all the services, employment, and so forth. So this is the governance structure. So we're trying to see, okay, so if you have this type of governance, how does it work with respect to how people are really moving in the space? So then we take from the census, data from the census regarding to commuting to work. So once you have the commuting to work, you have to clean up a bit the data, because of course you want to know what are the interactions with respect to daily commute. So we're going to get rid of all the ones that travel more than 3 hours. So for these type of things, you have the road network, and you compute more or less in order to see the relationship of the trips within the road network that are less than 3 hours. And then at the same time, you have a classification of occupations. So you have the type of how skilled are the workers that belong to this system. And so overall, you will have networks that look like the ones on your right-hand side. Yes, that are relationship between you have the census data, and you aggregate it at the city level, and then you look at the relationship between the different cities. So basically what you're going to do is you have the nodes are your cities, then the share of commuters is going to be the weight in your link. And finally, you're going to do a percolation process on this specific network, okay? That will look like what you're observing on the map that is on the right. And so how does it work? So you have a network like this one with weights, and then you're going to cluster the ones we have a higher weight. So you're going just to cut the network and get the higher weight. And so at the same time, you can construct your tree. So if you start from the beginning, at the threshold 5, there are no cities that have this amount of flow, this share. So you have all the different cities that are disconnected are the leaves of your tree, okay? Then you say, I'm going to look at the interactions that have at least this amount of strength, 4, yes? I'm going to see the most connected cities between them. And then I see here, I have my first cluster appearing. I have 4 cities that are like a system of cities, but nobody else is connected. So I can see already that in this very small example, I have one very important system of cities that need each other, as opposed to the other one that's in not to have such a strong interaction. And then I increase the amount of commuters that I'm taking into consideration. And then I see that I have another set of relationship between 2 cities. And I continue the process in this way so that I construct my tree. So I see how from the leaves, I start to see system of cities and maybe regions appearing in this specific example until I cluster the whole space. So once I have my tree that is telling me about the hierarchy and the relationship between them, then as you saw how we constructed this, we know that these ones here that have a mother cluster that they belong to earlier than, for example, A and F, they need to go all the way up to the tree in order to be connected. We know that these ones here are going to have a stronger dependencies between the different cities than, for example, A and F. Okay, so how can we measure this type of relationship? It's very easy. In biology, they do it all the time with respect to proteins and genes and these type of things. We measure the cophonetic distance. So how many steps you have to go up the tree in order to have the same common mother cluster. Yes. Then the second step. My God, I'm wondering where I send the right. The second step is to take all this to do the percolation in Chile, and then once you do that for the whole street network, sorry, no, it's not the street network, for the whole commuting flows, you end up with this structure, okay? So this structure is richer than the one that we saw from governance. In this structure, what you can see is that actually Santiago, so Santiago is the capital of Chile, and it's right in the middle here, yes. You have Santiago that has a very strong connection, and you can see how the colors don't necessarily line up with these ones, okay? So the colors that you see on your left-hand side are the colors of governance, while the colors that you see here are the colors, so they're same colors, but you see how they come together according to the strength of the interactions. So for some of them, straight away they get together, while for the cities that are in the north, for example, you can see how the cities in the north need to really go up the tree quite a few steps before they become one city, okay? One region, sorry. So here we can see how you have your cities at the bottom, systems of cities, provinces, regions, and macro regions, okay? Of how you can categorize all this. And this is the sort of networks that you obtain from this exercise, okay? As you increase the share of commuters that you allow, yes, you decrease the share of, you decrease the share of commuters. So a high share of commuting means a very strong interaction. So as you relax the system and you allow for only a few ones to commute in order to be able to capture them within your system, you see how these clusters grow. And you see how the one in the middle corresponding to Santiago is a very important one. So doing this exercise, we can see in particular examples like this one. So this is a region that was divided in two, and you can see how actually when you look at the commuting networks, it kind of works, okay? Because you have these cities that have a stronger interactions between them than with the one in the north, yes? So this is a new delimitation that was put in place that actually makes sense with respect of the interaction of how the commuting networks will be working. So now that we have our tree, so we have constructed our tree, take it into account the interaction between the cities, we want to see some measures of what's going on with these cities in our system. So the first thing we want to see is what is really, so we have a governance structure that assumes that everybody is at all the cities that belong to a region are in the same distance, okay? But it's not the case. Here we have how, if you take into account the commuters, you will see that the cities, all these cities have a stronger interaction than the cities over there. So all of these ones are the one in the middle, as opposed to, for example, over here, you can see that all the cities that are in the north have a very weak interaction between them. And all of these ones have also strong interaction, but not as strong as the one corresponding to Santiago, where the capital Santiago is. And so in this plot, I think it's nicer to see. So you see here you have from north to south, and then you can see these differences, right? So the ones right in the middle, where Santiago is, have a very strong relationship with respect to the cophonetic distance. It means that you can reach the mother cluster straight away. So they have a bigger attraction, more cohesiveness, if you want, between them. While the ones in the north seem to be more independent. Okay, so what about the diversity of the different flows? So if we look at the diversity of the different flows, we want to see from where all these commuters are coming from, right? So we can think about Shannon's entropy in order to characterize, all this diversity of the different flows from the different places. So basically what you want to know with this type of measure is, am I capturing people from only one place, or am I capturing people from different places in my system? So when I do this type of thing, so this is work that Valentina developed in this paper over here. So when I do this type of work, I need to normalize, of course, by the size of the network. Okay, so because we're going up up the tree, and you have a entropy which is additive, so you need to make sure that you're normalizing all the time so that you'll be able to compare from system to system. Otherwise, you wouldn't be able to do that. So when you do that, you have examples like this one. So when you look at these two systems, looking at the entropy, you are able to see whether you have a monocentric type of system or whether you have a polycentric type of system. So the one on the right-hand side is London, which is very monocentric, and the one on the left-hand side corresponds to the northern powerhouse, which is more polycentric. And so, of course, the entropy is reflecting this. So you have a high entropy for the northern powerhouse and a lower entropy for the greater southeast, which is the cluster where London is. So basically, it's a feeder for all these other things. But if you look closer at the system, then what about Leeds, for example? So even though the whole area is polycentric, you will still have many cities inside that are monocentric in that area, that are attracting lots of people. Yes. So when you're thinking about decision making and this type of things, is where am I in the system? This decision is going to impact at which level and how it's going to change this type of relationships. And on the other hand, you have the opposite. So you have a system like London that is very monocentric, but when you look closer at some subsystem in there, you will be able to find some polycentricity as well. So doing this exercise for the whole of Chile, we end up with a system like this one, okay? In which we have our hierarchical tree, and we have our clusters with the colors corresponding on how their entropy is changing. Warmer colors, high entropy, colder colors, low entropy, okay? So what's happening in this plot over there? So you have your cities, you compute the entropy, yes? Then you go to the next level and you recompute the entropy of the mother cluster. And you go to the next level and it's normalized so that you're able to compare from place to place. And what you observe is that sometimes, so here are two examples of how these networks work. So what you observe is that sometimes when you go up the tree, you're gaining entropy because you have more diversity of things, but sometimes you're not necessarily gaining entropy. So this is with respect to the commuting flows, the diversity of where all these people are coming from. So what you see, for example, in this plot here is that you have Los Angeles, who seem to be a place that attracts people from many different places, but at a very local scale. So once you go to the higher scale, once you go to the higher scale, and it is together with Concepcion, it loses this diversity of flows. Okay, so it's not necessarily the case that it will be gaining. It can also be losing depending on when you are in your system. If you consider Valdivia, on the other hand, it will have a good enough entropy, but as you allow and relax the number of commuters that are allowed into your system, you will see that it's gaining entropy. Okay, so it would allow for a more polycentric structure to take place. So this is what we have to think about. When a low entropy means a more monocentric structure, a high entropy means a more polycentric structure in this case. And when we think about the skills diversity, then you have a similar case as well. In some cases, you had a very high entropy and then you lose it. Okay, so you were very diverse, but as you allow commuters, it didn't really add to the system. That's what it means. Okay, I already had the skills in my city, and then as I'm allowing more commuters, are not adding into the system. On the other hand, you will have places that is quite the opposite, that they were not very diverse, and as they allow the commuters to come into place, they added into the diversity of this system here. So overall, what we have seen is that we have cities that, if you look at the diversity with respect to the commuters that we call the structural diversity, some of those will lose this diversity as you go into the regional level. And then you have places in which it's the other way around that they will be gaining. And the same for the skills diversity. Okay, so far we have seen, yes, Elsa, these little trees look nice with all the different colors, but how do we use them then in order to be able to talk about what we were saying at the beginning? You were saying that you need to be aware of where you are in the system in order to take decisions at the other level, and how this tree might change the relationships once you do an intervention and how it's going to trickle down. So one way to think about in the wider context is to look at the relationship of all the characteristics with respect to, in this case, the commuting, the diversity of commuting, and the job skills, and to see how one city changed these characteristics with respect to its whole scale as opposed to this other one. So basically what we want to do is to cluster all these different things in the tree in order to be able to characterize our cities, okay? So what is it that we have? We have in the tree, you know, at all these different levels, we have a diversity of commuting flows, and we also have diversity of skilled workers, okay? So you have 8 different thresholds that we're considering in each of those ones. So we have like 8 variables for commuting and 8 variables for our skills. And then we do a principal component analysis. And once we have this, we cluster that with k-means. And this is what we obtain, okay? So we obtain our cities according to our principal component analysis in these different quadrants, where the colors correspond to the cophonetic distance, okay? So you can look at the points. The points are the result of the clustering analysis, but the colors, they have nothing to do with the clustering analysis. The colors correspond of the cophonetic distance, so how close they are to each other. So colors that are, yes. So colors that are very dark correspond to smaller distance between the system, and colors that are very bright correspond to a larger distance. So overall, what you see here is a clustering of the different cities, and it very much corresponds to where they are in the system, how close they are to each other. So how close the interactions, how you define how do you define the system in terms of the interactions? it very much corresponds in terms of its characteristics, okay, which is, I think, a very insightful result. So you can think about it. In this case, we're thinking about commuting, but it has to do with transport, okay? It has to do with employment. It has to do with all these other variables. And what is it that we get? So, for example, what we see is that things we have. Let me tell you of these two different cases. We have here in this quadrant, we have these cities that are in the south, and these cities in the south have sorry, let me just so have a high commuting diversity at high scales. What does it mean? It means that these cities in the south are polycentric, okay? They're polycentric, but at high scales, so they don't interact as much, okay? So they're quite independent in that respect. While these cities over here, which correspond to where Santiago is, we can see that some of them, Santiago is quite different to the other one, because Santiago plays, it's a hub in the whole system. So Santiago, it's quite diverse, and it doesn't add to the diversity. But the other cities, once they reach into Santiago, it adds into the diversity. So if I'm going to be taking a decision, where is it that I am in these quadrants in order to be able to understand? Do I need complementarity of types of skills that I'm here? Do I need to put a new infrastructure project in order to be able to reach all these other regions, and how this is going to change the whole structure of the tree?